Hi all. So recently, in order to begin you go, I was using a sort of tool available within this fantastic Sabaki GUI, and the tool is known as the influence map estimator. So just to give an idea, what do I mean by saying that? So let's say we just play a few stones, not even like this, but probably let's make it like so. And let's approach this way, and I don't even know, let's probably do this. So now here, if I simply say estimate, then you see like these areas, the white areas are like occupied by white, the territory that is sort of potentially might become the white territory, might turn into white's territory. And this one in particular, this black shades, are those points that should have become like black's territory. Now, just to give you an idea, so for instance, if we do the following, if we do like increase in this, and just to estimate like so, then you see like the territory is getting bigger. However, if at this point we do the 3-3 invasion, which I'm not quite sure whether it works here or not, it should be working really, and then do the estimate again, then it turns out that suddenly like black's territory started being demolished and like no longer works. So the corner is no longer like something that belongs to black, and instead you see like white is doing seemingly better here. So arguable, but anyway. And also it gives a difference, like who is better, like it counts all of these points like for whites and for blacks, and assuming the comma 6.5, it just gives the best move, like not the best move, it gives the score who is ahead according to this static estimation. So I was thinking like this looks like a perfect evaluation function, isn't it? And if we're not talking about like such tactical tasks as like killing the dragon in the center of the board, or trying to avoid the opponent making 2 eyes, not talking about the death stones, and not talking about some tactical complications like capture races, things like that. In that case, if we're playing a very peaceful and calm go, so like the most, like the most difficult thing is to, like when you want to tanuki means like play somewhere else. Well, when the forced move is no longer like there are no more forced moves, like the tanuki move, like if we compare this to chess programming, it's something like the quest in search has been completed and we have come up with a quiet position. So the move in the quiet position that is supposed to be drafting more territory potentially for either side can be called tanuki. This is my understanding. I might be not 100% sure, but anyway. So I was thinking, what if we could write a simple program that would be taking the given board position as an input, and then trying to play every single move available on the board, and then answering the simple question, which of those moves results in the biggest estimation, so this number. So that's what I was wondering about really. And I don't know, writing this sort of thing on my own, I don't quite know how to do this, but fortunately what we have is the following. So we actually have, don't save, this Sabaki HQ GitHub repo where the Sabaki GUI is available. But Sabaki GUI is a bundle of many smaller applications, and one of those applications is actually this one. It's known called Influence. So this module does what you just seen on board when you click on the estimate feature, estimate button. So let's try to build a sample from here, and then we'll see we can actually write a simple like function to loop over the board squares and try to evaluate what we have here. The only bit of a problem, I'm not quite sure. Yeah, so somehow needs to make the moves in here. So board data. So it probably relies on the board. Oh, data is the board data. So yeah, there is another module, the board data. Or I can probably do this even like altering the source code. I don't want to write the full-blown application just right now at the moment. I just want to quickly try this and see if it works. So that's the only thing I'm really interested in. Okay, so npm install Sebaki influence. I've already done that, but let's walk through this steps one more time. So yes, I've already git cloned this one. So let's get in here, open in terminal. So I've just git cloned like this, right? And let's try to influence this by npm install. So I already have that installed. All right. Yeah, good. And then what? And then so we'll come to this a bit later. So for now, what we want to do, so this is the documentation, we just go to build the demo. So let's build the demo. So we just clone the repository, already changed directory to influence. Now let's do npm install, and then so let's do npm install, and then npm run build demo. Then do npm run build demo. And this produces, if we go to the demo folder here, so it produces this index.html. I really need to check out the source code also. And this is what we have here. So no map, so influence map goes like this. Discrete influence map, I'm not quite sure what's the difference between these two. So it's just like, yeah, so just gets more shaded, but I'm not quite sure what the difference. But this one looks exactly what we're looking for. So show area map is just those places occupied by stones, like the actual territory. So this gives the actual territory, if any, like here, but mostly there is no territory. The nearest neighbor, well, so not interested in these really. So ultimately interested in this influence map. That's pretty much all about it. And I just want to quickly check that out. So let's just see the page source. It should be just, okay. So bundle.js, and it's pretty much all about it. Not quite sure what the main.js is all about. Let's quickly have a look. What is the main.js is all about? Okay, original sign map. Okay. Oh, well, this looks like the Node.js code. It's not the browser code, definitely. Yeah, so probably the bundle is, yeah, it's just sort of converted to, oh, well, yeah, just, okay. So just probably translates this code into a browser specific one. So well, since we don't quite need browser here, I would be quite pretty satisfied with the command line application, because yes, I just want to being able to input something there and then just see what would be the best move. And I don't even need the routine to enter the moves, because I can just manually like change in the code. So I'm quite interested if we create two-way radio box. Oh, it's just creating the GUI, definitely. Max map value. Difference maps extends. Well, I'm not quite sure. So when it does what? Show area map. Stay key. Well, let's probably try now to run the example. So if I just do like, okay, if I just create a folder, let's call it big move. Okay, so find the big move, and empty document, let's call it big move HTML. And oh, hold on a sec. No, it's not going to be HTML. We're going to be writing this over Node.js. Let's just call it big move.js instead. And let's open the terminal in here. Okay. And I want to try this examples from in here. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it's 9 by 9 board. So we want the 19 by 19 board instead. Board data. That's quite interesting. Board data. So this is how the board data is going to look like, which is good. Okay, let's try to import this first and see if this ever works. So now Node.js the big move, Node big move JS. Wow, cannot find module Sabaki influence. Well, that's interesting. Why? Because ultimately we did actually oh yeah, okay, I need to, yeah, this is Node.js. I need to do, yeah, this is Node.js, it's not working that way. Yeah, I'm sorry, let's just do this from scratch, delete. Actually don't need to delete this, I just need to do npm init, I guess -y to not avoid answering any questions. And now npm install, and yes, this one influence. I just want to install this locally. So yeah, I would now create the node modules. What? npm. So this would now create the okay, package JSON, so it should create the node modules. Okay, so now this should be working. Hopefully this should be just fine. And again, big move JS, and here we go. Okay, now it works. Cool. So well, let's try first with this example data. Copy. Yeah, just pass the pointer to the data. So that's pretty much all about it. So area map. So let's just try this simple area map without much reinventing the wheel. Okay. No. Okay, Mac again. What are you doing? This one. Okay. Okay. So so this is going to be our board. Let's make it even variable. And so what's the API call? So influence area map and pass in the data. So let's call it data. Okay. Let's call it result. And this probably should be the array. Console log and result. Okay. Yes, so is this? Yeah, it seems like. Okay, so now let's go for experimenting. So yes, I think that I can change the board size however I want. So let's do it like 19 by 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so this should not contain any influence by now. Yes, but so we have one for this stone. So let's try one. So I just want to recreate the position I had previously on board. -1. So we have one here. Okay, and 4, 4. It's not 4. It's actually 3, 3. It's not 4, 4. Okay. Anyway. Yeah, we'll change this later. We will change this later. It's not a big deal. So, well, this is strange. So I'm not quite sure. Does it just let's read about it. Returns an array of arrays of the same size as data. Each entry is either -1, 0, or 1, corresponding to white area, neutral area, and black area. Well, that's exactly what I'm looking for. But for some unknown reason... Okay, so if I just try to make it a bit more like this. So it doesn't yet seem to... No, it seems like it's just the copy of the initial board. Influence area map. Well, this is strange. I have no idea. This is really strange, to be honest. Okay, let's try something else. Let's try just map. Yeah, I wasn't trying this before. Oh, this looks like the standard JavaScript map function, so hopefully names would be just okay. Oh my god, what is this? Well, this is interesting. There's some values already. Returns an array of arrays of the same size as data. Just renders it a bit differently, but each entry is numbered between -1 and 1 inclusive. Oh, so no zeros there. Okay. A negative number corresponds to white influence, whereas a positive number denotes black influence. This map does not take that stones into account. Okay. If discrete is set to true, the map will only contain... Oh yeah, so this discrete is exactly what we had here. So discrete influence map. So the idea is that this one, it's like so it's like more, less. Yeah, so this is like more shaded, this is less shaded, and hence the reason behind these values. So they're not like, yeah, okay, so I got it. So it's like a heat map at some point. So it has like more shaded, less shaded, and the more shaded it is, the more like, okay, the more shaded it is, the bigger probability of this particular vertex to become a territory for one's given site. So we need to use this discrete. Well, this is getting really cool. So discrete set to true. Options. So if I just do, I don't know, probably if I just do like this, is this really going to work? So what's wrong with this? Okay. No, it's still okay. So how can I specify the option? Default is false. Okay, influence map. Let me just, I just want to see the how that gets called, because I'm not quite sure. Main.js. So oh, this is how they use the parameters. Okay, discrete. Okay, so the parameters are actually like, it's just an object. I had no idea this is the object. Discrete true. Okay, fantastic. Yeah, this is really fantastic now. So you see, although the layout is not really quite as good, but we have these ones, minus one, so those areas is actually being mapped properly. Yeah, so this is really cool. So now what I want to do next, so yeah, this is now getting really interesting. So so now this result would always contain the same. So yeah, I will be inputting the moves manually, so I don't need anything else here. But let's create the function. Let's call it count. Function count. So for let row is equal to 0, row is less than data length, and row plus plus, and same for call. Here let's say data whatever 0, call and call and call. So here let's say white score 0 and black score is equal to 0. So let square is equal to, well, it's a two-dimensional array. We don't need to calculate the square specifically. We can just do data row and call. So if data row, let's first just print this. Actually, you can do the console log. So just want to print them separately and count. So it's better even call it, yes, it would be count. Yeah, this is count. Let's go for it. Okay, so 0, 0 is minus 1. Yeah, so this should be it. Or is it? Minus 1. Oh, no, not the data, but the result. So let's say board like this. Say board here. So yeah, so just the pointer is pointing to the initial one, to the run source. So count for result, please. Is this fine? Yeah. So now this should be okay. Still the same. Something is getting wrong. Oh, here I should do the board as well. All right, now this should work. Okay, fantastic. Now we have these. So now we can say if the value is greater than 0, so just to recall which are black and which are white, so map -1, 0, 1 corresponding white, neutral and black. So -1 is white, so bigger than 0 is black. In this case, black score plus equals 1, and if this is less than 0, then white score plus equals 1. And by the end, let's return probably an array. So let's say black score and white score. I could probably, yeah, let's just do this like this for now. So count result and let it be C, console log and C. So I now should see the number. Yeah, so the first is white, the second is black. No, first is black. So we see that black is bigger. Okay. Okay, so now I need to think. So I just want to only return the difference. So let's say return black score minus white score. Okay. So 17. And this, so if it's plausible, this means that it's better for black. However, if we do, it's better for black, but if we do like this, for instance, now it should be minus, so it means that white a bit better. So this is somewhat like the evaluation function returns in chess program for alphabet Enigmax search framework. So if it's plausible, then it favors white. If it's not plausible, it favors black. If it's plausible, if it's not plausible, it favors white. Okay, this is good enough. And now our goal is to predict the next move. We are not taking into account the response by the opponent. So let's drop back to the very initial sort of setup. All right. Yeah, this works nicely. Big move.js. Okay, 0. This is good. Okay, so now let's call it function generate move. And now what I want to do here, I want to loop over all of the board squares. So just loop over all of the board squares. And for every square, so I want to call count. So let just count and result. Yes. So we do this influence, yeah. So we do, yeah, just do this once for now. Yeah, this is pretty okay so far. So count the result, and yeah. But hold on a sec. No. I want to change, and yeah. So hold on a sec. Not like this. What I actually want to do in here is, so the first thing here, so I can say if board row and call only if it is equal to 0, because we don't want to override the stones, then we are indeed, yes, running this function on this data, which is good. And then what? And then we want to count copy, cut, and let's also decide to move. Okay, and I want to generate move for, let be 1 and -1, right? So 1 is black, -1 is so let's say okay, we don't need those constants really. So this is would be for black. So now this should print the number of results. Let's print this C. What don't you like? Board is not defined. Okay. Generate move. Let's make data. Yeah, so we are working now with our initial data with this one. Okay. Okay, all zeros so far. Well, it takes time, but that's okay. That's okay. And now we no longer put the stone, so we want to say data row and call equals the site, so this would be either 1 or -1, and then we drop back. So this is sort of a make move. This might not be legal, we're not getting bothered by legality checking for now, but generally okay. And here just gets back to 0. So now well, it's quite interesting. So it gives, so what is it, 361? So I'm a bit confused. Oh, that's because it just counts all of the okay. So let's return here for now, just for now. Just want to make sure that console log, say data, so it should be the top left one is set to 1. Okay, and Now it should be dropped back. Yes, it is dropped back now, which is good. So what's wrong? So if we bring the result, let's bring the result in here. Oh, hold on a sec. Well, it just gives, okay, so it gives, yeah, the idea is that, yeah, it thinks that the entire territory belongs to the site to move. So that's probably, if we do like, we just do, let's do some 4 stones here, and here. Now it's, yeah, now it just works nicely. So we want to avoid this, so if the result is 361, if the result is 361, we just want to ignore okay, so here let's say if yeah, so it's not going to be working from the starting position. It's a bit of a downside, but and let's say if C is equal to 361, then we will return the best move, like the corner move, like 4-4 for instance, like the pre-coded hard-coded one. Okay, so let me think more. But then it would be better. So these counts. So let candidates is equal to this one. So well, actually, so yeah, and the scores. So let's, because I'm wondering, can I do math max after? Yeah, just hold on a sec. If I just say math max and 1 2 3, is this going to give me 3? Nope. Okay, I'm sorry guys, I don't know how to take the biggest number in JavaScript. So biggest number from array. Yeah, max. So what's wrong with this? So what did they do the different way? Oh, I needed to. Oh, just the array. Okay, so if I just do what how is that different? What are these 3 dots are standing for? It's a bit weird. Okay. Seeing this syntax for the very first time in my life ever. Oh, this is cool. Okay. So, yeah, I'm sorry, just one didn't really want to. So here we just want to return. So what I want to return is the best move. So here this would be 0 0 1 2 3. Sorry, 18, 17, 16, 15, 15, 3, 315. 0, 1, 2, 3. Yeah, I just want to return hardcode returning this one in case we have the 361, which like empty board. So an empty board, we want to so here I want to return top right 4 4 move on if empty board. Empty board. Okay, so this already should be so lab best move and console log the best move. So on otherwise empty board goes the 315. So now just to make sure that this is indeed, so if I just say data, data 315 is equal to like this, and just to make sure that that's exactly the move. Yeah, 4 point. Yeah, this is okay. Yeah, it's good. Okay, I'm pretty satisfied with this. So, but otherwise, so it's not, if the value of C is different, in that case, we want to append the scores, append score, so we can say scores dot push, and what is the score? The count, right? Count. Okay. And also we want to say to append candidates, right? So candidates dot push. And how do I know? Yes, row and call, the current row and call. Candidates push row and call, right? Yeah, this should be really cool. So now I don't want to return in here, and instead I just want to say console.log scores and then the candidates. Okay, it's not what I wanted to have. Yes, going something horribly wrong. Oh well, that's because I have the empty board, otherwise empty board. So let's say I put it here, and now I try to generate the best move for -1. Okay, so these are our scores, which is really good. All right, so this is good. So now I need to distinguish so I probably first need to filter or like take only the positive values. How do I do this? How do I do this? Yes, okay, I need to find the maximal number. So yeah, I need to find the maximal number, and if the value is positive, it favors black. So let's just try, let's just try first doing this, just the maximum number. what would be one? So scores. Nope. So I don't want to log this one. It's quite a heavy function. It really takes time. Okay, 21 is the best one. And if there is not the only 21, yeah. So how do I need to somehow associate so maybe, yeah, it's just, I'm not quite sure how would I make the data structure so that I could associate the best score with the best move, and still can be able to filter that. So if I push the score, so I can make it an object, obviously, but in that case, and does this mux actually return the largest of given numbers? Okay, just returns the largest number. I'm interested in the index. I am interested in the index. So yeah, I need to think, how can I make it okay, so since I need to reference the index somehow, I'll probably write the custom. So I'll write the custom function here. So I want to find best score and move. So for let I is equal to 0, I is less than scores dot length, length I plus plus. So let's start by saying scores I. Let's go. So still have this. Okay, so let best score is equal to 0. Let's say minus infinity, somewhat like this. So I can simply say if scores indexed by I is greater than the best score, then the best score is equal to scores indexed by I. And also this index now points to exactly the move that we're interested in, the candidates. So let's say let best move is equal to, like, I don't know, -1. So in here, the best move is equal to candidates indexed by I. So pick up the corresponding one. This should work in my dreams. Yeah. And yeah, so by the end, we want to return the best move. And do we want to, well, okay, hold on a sec. So this would be the best move for black. No, not so fast. Not so fast. Not so fast. So now the best move. So this only works if side is 1. So if side is equal to 1, in this case so yeah, I would rather return the best score, but no. Yeah, okay, let's just do this. Let's not be so let's do like a very dumb way. So let's make it minimax. So if side is equal to 1, in this case this is the code. Go for a bit of duplications, but for the sake of simplicity and clarity for now, so I just do it like this. So if side is equal to -1, then the best score is like this. And if this is less, yes. Okay. And now all I need to do is just to return the best move. Well, in theory this should work. So this one for black, this one is going to be for white. Okay, so is this really going to work now? So console log. So let's even make this move on board. So say data. So let's say let call. Nope. How do we push the best move? Row call. Okay. Row best move 0. Let call best move 1. Okay. So make move on board. So row and column is equal to side is equal to -1. Side. Okay, and console log the data, and then console log the best move. Okay, all right. So let's give it a try. Best move is not defined. Oh, so I need to return separately then. It's a bit of redundancy, but yeah. So let's go for it. 0, 5. Oh, that's definitely not the best move. This is definitely not the best move. Okay, yeah, let me just, yeah, probably maybe something wrong with this code. So, let me just make this side equal to 1. So just make one more move for blacks. Okay, what's wrong? What is wrong? I don't understand. Oh, it doesn't even get there. Okay, yeah, let's get rid of this fantastic line of code. And it brings the first one because it's the best. Like, okay, if I just want to put, yeah, so okay, I don't care about the sudden position, so let's start from this one. So 0, 6. Well, this is bullshit. This can't be true. And it's black, so he gets there. Definitely gets there. Yeah, let's debug. Let's go for debugging. Okay, at very least, here, just want to have a look what my best score is equal to. So, log the best score. It should be at least plausible. 45. 45. I don't quite understand what is wrong there. I don't quite understand, to be honest. Should now give a list. Okay, 20. Okay, let me, since it's not really that much. Okay, it's not that much, so let me please print best score and the best move. Oh, hold on a sec. Yes, candidates, yes, the best move should be working. I probably can't do that with console log. Well, actually I can, okay. Oh, this yeah, so it actually does what it does. It gives a 0, 6, but what's going so horribly wrong? So it just picks up some absolutely weird, absolutely weird. Oh, hold on a sec. Hold on a sec. Yeah, this is all going wrong. So I should be doing this. I should be doing this. Should be doing this for every single iteration. Yeah. Or am I? We make move, take back. No, hold on a sec. Hold on a sec. This was just fine. Okay, this was just fine. I don't like where I'm forced to think. Yeah, that's because I don't return anything. So just want to manually see the scores and the candidates. Like this, like all of those available there. I'm not quite sure where did I mess up with the code, so for some reason I just try to see. So how is that possible that 29 is returned by... So actually this is already the biggest. This is so weird. How is that possible? How is that possible? Okay, what if I try to change this a little bit? If I do this on the fly. Yes, what if I actually do this on the fly? So let me try that as well. So if I don't push anything here. If I don't push anything here. Yeah, then I need to keep maintaining this, the best move and the best score. Well, okay. Let best score is equal, so side is equal to 1, then the best score is minus 999 other, like this. Okay, this is good. Now best move, let's make it like this. Okay, so I don't push anything here. So try to evaluate that right over in here. So I got this count. So here, say if side is equal to 1 and if side is equal to minus 1, So let's just for now say console log, and yes, console log, and the best score should be minus 9999 many times. Yes, this is good. All right, and now so let's print, I just want to print the count. I want to print the row and the column. Like what he does. Oh, function count, no, not like this. I don't quite understand what the heck is this. Why the 45 is in here? Why 45 is here? So can I please then print the result every time? So something is getting messed up here. I just want to visually see what's going on there. Just want to see visually what is going on there, because it feels horribly wrong. Oh, do you really want to say that if I'm putting the stone over in here, so it seems like this is the stone. Okay, so this is the source of confusion. So probably if I do, yeah, if I put the stone, so let's do some trick. So it just considers this firstmost to be the best, but they're on the very like edge of the board, which is horrible for opening. So if I say not greater than, but so that would be overriding those as well. So I can say if score is greater equals, so if this count is greater equals than the best score. Yeah, I could have actually even keep sticking to this code, but I don't want to. So yeah, now if I do this again, so if I just do this greater, then it will give me only the first few. Okay. What's wrong? Hold on a sec, clear. So doing so many, this is very strange. Is this really all of the time better? Oh, no, I just want to yeah, so let's inspect. So let's inspect. So yeah, he's moving the stone. Was here. So now it's probably here. Yes, 1, 5. like 0 1 0 1 2 3 4 5 maybe. Okay, so anyway, it's just moving the stone, moving. So what's going to happen later? I don't understand. 7 6 count. Am I doing this for black now? Yes, I do. Zero, 1 2 3 4 5 6 7. So here it is, but I'm really surprised, like, where? So why it doesn't give you any influence in here? So yeah, I need to go for, so before ever doing this, I don't need this anymore apparently. What I want to do, I want to manually do this. So I don't want to generate anything. I just want, yeah, so I was a bit in a hurry, shouldn't have to do that. So console log. So just put the result in. So let's say 0 0, and my initial one has only these 2 stones. Okay, so just want to make sure you have the exactly the result I'm looking for. So yes, like this. Okay, so if I do print, let me print the data first. So I put the stone here. Okay, let's print the data and console log, and let's print the result. So actually this result, like, let's call it, so I probably can't use word influence, let's call it heat map. Or it's just better call it estimate. Count estimate. And print the estimate. So all right. Oh, that's unfortunate. Noob's way. Okay, so so we put this, we put a stone here, and this is okay. This is good. So if I put it on the 4 4, which indexes 3 3, just to have the visual. It's not quite changed. It didn't quite change, you see. But if the stone is placed in here, then it's really strange. Like, why is that? Yeah, so I'm really confused with the behavior of how this estimator is actually working. So, okay, let's try somewhat like 7, 7. So it doesn't seem to give any estimate in here, which is weird. Okay, so let it be 7, 0, for instance. Yeah, I was like, I have something in my head like how this is supposed to be working, but yeah, it's so strange. So we have the stone placed here, and the influence shown 0, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this 6 is actually the parameter. The parameter of what? The parameter. So this might be variable. Oh, I just want to find this. Max distance. Max radius. So if we just try to play around with this max distance, let's say 4. So this should be now giving me a shorter one. Nope, are you kidding me? So this is the move. Max distance number. So maybe you give me an error if something is going wrong. No, it doesn't. Just max distance. I'm not quite sure. For some reason it doesn't react to this. Max distance. Doesn't seem to be reacting to that. Well, I don't care much about this now anyway, but it's a bit strange, it's a bit weird. It's a bit weird. Okay, let it be 6, that's fine. Okay, we stop moving these. Yeah, the behavior is really strange. Like, why gives the influence towards the center when it's like on the board edge? So moving one step to the right. So didn't quite change much here. Moving one more to the right. Okay. Well, this is so strange. This is really, really strange. Well, I could have like avoid lower than rank 2, for instance, for this program, like, but yeah, this limits the scope. Ultimately, this really like limits the scope. 0, 1, 2, 3. So now it's in here. Okay, so now this is how the influence is actually looks like. So if I put it even more, this should be okay. Now this is how it's working. So just potentially secure something in here, but okay. Yeah, so the problem is that for some unknown reason, if the stone is on the board edge, it gives absolutely weird influence result. So is this the nature of the estimator, or what the heck is going on there? So let's try to quickly check this out on the real board. So if I say like here, here, and here, so estimate please. Yeah, you see, this is weird because this is not really that much of truth. This is actually how it's working. I couldn't ever imagine this is going to be working like that because I never played this, the first line. Okay, but anyway, if we try to, so yeah, here, it's probably also, yeah, so that's the nature of, yeah, so it gives bigger influence. Well, what is the most weird thing in this regards is that according to this, like, to just the bare count, it would be trying to place the stones exactly on the first rank, on the first lines. It's weird. It's not has to be done like that. So I probably need to restrict this calculations to, if I try just not, like at least here, 0, 1, 2, at least here, estimate. Yes, probably 0, 1. So I need to go for some restrictions there. Yes, don't save. So this is still fine. Yeah, I could never imagine this. This is going to be on the cards this way. Okay. So let's put a condition. Yeah, hold on a sec. Before putting a condition, let's just keep this one. Okay, so just should print all of the available. Oh no, 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 no. Yeah, so let's just hold on a sec. It's clear. And okay, so it does this once. So let's say if the row, in this case, this particular case, we can say if row is less than 0, 1, 2, it's less than 2, then continue. Clear? And let's go. So now yes, it's not still yet that clear. The influence is okay, but if I can just please the data console log. Okay, clear. Okay, so move starts from here. Okay, and now and this gives a sort of influence as well. Yeah, and that's also restrict. Yeah, so this estimator is working quite interestingly. So yeah, I need to go for some restrictions to make it work better. This is incredibly interesting heuristics to try for actual play. So hopefully by the end of this video we can do that. Okay, so and now here, if call is less than 2, then also continue. So now it should start in from the 3, 3 point. Yes, so starting from the 3, 3 point. 0, 1, 2, 3, 1, 2, 3, yeah. And that's the influence. So now, yeah, what would be the biggest move? Yeah, so now there should be, so yeah, now we'll just avoid doing those weird moves like on the board edge, which I had no idea would actually try doing those. So here we do override. We do override things here. So I just want to say the C, so the best score is equal to count. Yeah, so now we'll be overriding only those that are better. And the best move is equal to, yes, row and call. no, clear. Now it should just print less, only those, yeah, now prints less. So this one here, now this one seemingly like takes a bit more according to the estimator. And this is quite interesting, yeah, so here as opposed to here, okay. Oh, and 31. Okay, so I also need to restrict this the opposite side because it just, yeah, it goes for weird moves again. So, if, and row is greater than is greater than 19, but from 0 18, so it's 18 17 16 16 and call greater than 16. So just to avoid him playing on the board edges. Okay, clear. Yeah, now this is really getting interesting. This looks like what we're supposed to be really of what the. Oh, what have I done? Or not and. Okay. So this is the candidate move and the heat map. This is the candidate move and the heat map. Then this is the candidate move, which, okay. So yeah, since it demolishes black's territory, it's even better. Okay, I really love this one. And yeah, this already looks like something interesting. So 14.2. 0 1 2. Oh, this is the very last one. So it's still something that goes horribly wrong with the very last one. Okay, so we just still, yeah, the last move considered is still quite weird. I just want to have a look at the last generated. The last actually generated 2 3 0 1 2. Oh, okay, this one, yeah. It's a bit strange. So he considers this move to be the best one. Well, this makes perfect sense. Okay, so invasion, sort of invasion, sort of makes sense. But why calls it 2? What are the 2 3? Row and call. Row and call. 0 1 2 0 1 2 3, but there is nothing there. 0 1 2 0 1 2. This also doesn't work. Oh, 14.2, yeah, 14.2. Now this makes perfect sense. Yeah, 14.2. This is 14.2, and this is 2 3. Okay, okay. Just appends from the bottom. Okay. Yes, and here we need to return. Yeah, I just returned this one. So I just want to return the best move. And let's not do anything here anymore. Okay, and let's finally try to print this actual best move. Yes, 14.2, so this is the best move he found. Yeah, this already looks like a very interesting thing. So, okay, just 0, 1, 2, 3, 4. Is this index or the coordinates? So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But it's actually 15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I need to make this plus 1. So best move 0 plus 1. And best move, so make it more human readable, plus 1. Okay. 15.3. Okay. Yeah, now we are ready to play the game. We're really supposed to be ready to play the game, to test this, because I'm really wondering how can this work, if it ever can. So let's say best move. Okay. Okay. All right, okay. So now this is yes, I want to automate the matter of me. Oh, I probably can't do that really, so I need to be shifting this all the time. But anyway, this might be worth it. So my initial board position is like this. So let's try to generate the move for the other side. So now it's not supposed to be working so far. So this would now be 0, 0 if we change the side to -1, because we don't yet have the code to handle that. Right? Yeah, 0, 0, 0, or 1, 1. Yeah, because it just returns the best move by default. So here, if count is less than the best score, then do the same thing here. Right? $3.16. Whoa, interestingly. Yeah, so just this is what it's doing. This is what it's doing. Okay, and if, for instance, say if I put this stone not here but say here, so what is he going to do in that case? Yeah, here touches anyway. Well, this is really interesting. This is a little bit unexpected. If I do nothing, then what happens if I do nothing? Oh, if I do nothing, it just takes the 3 point of the corner, which is super solid territorial move. This is really interesting. So we can actually try to play versus this absolutely from the empty board from now on, which is really cool. Okay, so let's say it's supposed to be playing white, playing black. Well, it's not going to be making the move in the top right corner, but in the top left because of the indexing. But anyway, that's also good enough. But actually, to make it playing on the right corner, if I just switch the board traversal from, but I don't want this. Okay, really, I don't want this. Okay, guys. So very interestingly, we are coming to big testing. I think that it will be actually possible now to try this big testing. Yeah, so probably playing versus another engine is a bit too much, so let's try to play versus it Yes, the problem is it considers this attacking moves which attach into the stones. I was just thinking it would be just doing just like grabbing the territory, but it turns out to improve the territory goes for an attack or invasion or something like. Okay, anyway, so I play here and I play here, so 4-4. Okay, doing everything by hands, and big move. So the best move is 3-3. Oh, okay, that's because, oh, it's also interesting. So if it's the same color, it's actually trying to grab even more territory like this, which makes absolutely perfect sense. Okay, so yeah, actually now we want to say this -1 because this is white to respond. Oh yeah, so just to make it even, hold on a sec, just to make it 100% fair, so I will be playing white and he'll be playing black. So the first move he plays is this 3-3, super solid. Okay, let's make a new game here, don't save. Okay, yes, super solid. Okay, so he plays the 3-3 point. Okay, 3-3. Okay, super solid. Okay, I just take this corner in this case. So now he played here. Right? 0-1-2, 0-1-2, yeah, 3-3. And I play 0-1-2-3, 0-1-2-3. I play here. I play with this move. Okay, so now switching the side. Yeah, I could have automated this a bit more, but I'm so tempted just to try this right out, just right now. I'm really wondering. Okay, 17-4, so he takes, whoa, this is interesting. Okay, now hold on a sec, that's because, nope. He's always, no, I don't need to change the side. I don't need to change the side. He's always playing for black, right? He's not trying to make him playing versus itself. He's always playing for black. 3-16. So he attaches below. So he attaches over here. And like this. Okay, so you try to get into my corner. Oh, I don't know this xiangqi. Oh, what to do? Well, if I play here, then he can cut. I don't want the complications. I don't really want. Okay, let me just try to do this instead. So try to do this, and let's move. 17-4. Okay, he goes 1, 2, so 4 and 17. So here, right? He goes here. Goes here. Yeah. Okay. So what do I respond to him? Well, I don't know. Let's just 1, 2, 3. Let's do the 3-space jump. Well, actually, I don't really want him to take the corner. So maybe let's not give him the corner. And so did I put this to the proper place? And probably I did. Okay. (15-17). where is the move? Okay, so he just grabs. Well, this is cool. A bit of a Shusaku style play at some point. So 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3. So he plays it here. Nope. No. 1, 2, 3, 4, 5. He plays it here. Is this not correct? Seems like. Is it? Yes, it is. Okay. 1, 2, 3. 1, 2, 3, 4, 5. Whoa! This is cool. I really love how he plays. Like, he doesn't know anything, literally anything about, like, he doesn't know anything about capturing, but he knows about territory. And what he tries to do, he tries to make some territory. Did anyone actually ever written, anyone ever written a Go engine that would be like trying to play the game only bearing on this heuristics? This is really interesting to me. Okay, so I could have pincer. I don't want to go for complications. Well, so since he so what do I want to play here? So yeah, let's try to play. Well, okay, maybe try not to. I don't want to go for complications. I don't want attaching stones or anything alike. But on the other hand, so what would I play? So what would I play? What would I play? Okay, let's try here. Although it's probably not the move I play, but let's just try that. Well, this is getting really exciting. Seventeen. So is this the 3-3 point? Okay. So he plays here. So he secures the corner, which makes absolutely perfect sense. So, well, let's try this one. So, a peep here. So how does he react to this peep? How does he react? 17-12. Where is the 17? Oh, where is the 17? Oh, here it is. Whoa. So 1, 2, 3. 1, 2. Oh my God, he's attacking my group of stones. Holy crap. Can you believe this? Just based on the bare territory estimation. What a fantastic move. I can't believe my eyes. I really can't believe my eyes. Amazing. This is really amazing. This is really so amazing. Okay, I just keep this group. Well, he doesn't know anything about the dead stones so far. So, well, a little bit like this is fantastic. Okay, let's try this. Let's try this. Oh, hold on a sec. I just had the wrong. Do I have the wrong board position? 0, 1, 2. 0, 1, 2, 3, 4. 0, 1, 2, 3. Oh, I put this in the wrong place. Oh yeah. Just I fooled the engine a little bit. So this actually had to be 3, 0, 1, 2, 3. Okay, I'm sorry. So just fooled you a little bit. But I hope this didn't really. Well, it actually. So it just was not the exact position, but anyway, so here, so now this should be, so just trying to synchronize things. 17.3. Oh, so he goes like one space jump like this. He's trying to secure his territory. Okay, if I go further on, if I try to attack him, (17.3), 13, 17. Just hold on a sec. I can't see the board. Oh, it's just not been printed that nicely. 17, 13, 18. So here, no. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here, right? Yes, and that's where he played. That's where he has played in here. But it was already there. So I don't quite understand. So 3 stones, yeah, 3 stones he has. So okay, something has gone wrong. So what's the current board position? So this is the current board position. Okay, so this stone is already. Oh, the stone wasn't there yet. Okay, the stone wasn't there. Stone just wasn't there yet. Okay, 3, 9. Is he going here? No. Hold on. What was he? No. Hold on a sec. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Oh, come on. Where is the... I don't understand. 3, 9. 1, 2, 3, 4, 5, 6, 7. No, hold on a sec. 1, 2, 3. This is the row. This is the move. Or is it? Oh, this is the move. 1, 2, 3, 4, 5, 6, 7, 8. Yes, this is the move. 3, 9. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Fantastic play. Very territorial player. He's a very territorial player. This is so interesting. This is getting extremely cool. 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So how am I supposed to respond to him? Well, obviously, so I can now start cutting these stones and he knows nothing about that. So the heuristic is not supposed to be working that way. So I would rather try to just grab some territory here. So make a 3 space jump. And 1, 2, 3. So make a 3 space jump and see how he reacts to these. So I'm only interested like the compositional moves. Obviously he knows nothing about like capture ace or something like. So yeah. So 8, 17. 8, 17. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 19. 18, 17. No, so he plays here. Oh, what a smart guy he is. This is very simple. Yeah, this is the move. This is very simple. However, yeah, well, this is not good move because of this response. Yes, this is not a good move because of this response in particular. Just this stone is going to die after, most likely. So yeah, it's also like should like bear in mind like the tactical complications after considering the biggest positional move that is supposed to be reducing opponent's territory. But anyway, this looks like a real game of Go. Oh my god, can you believe this? I can't believe it. This is so exciting. So we can actually try to build a sort of a bot out of this. A Go playing bot that would be relying on this exact heuristics. Yeah, this might be extremely, incredibly interesting. Well, I don't know about you guys, but I feel absolutely amazed by this. This is so exciting. So this really allows us, like, he's a very territorial player, so only playing on this the third line. So yeah, this still can be tuned. This still can be tuned, though. Yeah, so we just add some real territory, like, yeah. So like only relying on this heuristics is not really enough for playing the actual game, but as like this is something that looks like a p-square table in chess. Well, for me personally, this is really a similar thing. I don't know if anyone actually tried to like make use of it to make an engine playing this style. So I'm not quite sure whether GNU Go uses something alike or not. I'm not quite sure, but really, like, I was inspecting the source code, but I didn't quite find anything like that would be doing something like this. But yeah, this is so exciting, so amazing. Well, okay, so I really now need to like try some more and potentially like even trying to turn this into sort of a plain program. I believe that could be really like extremely fun. And if I ever succeed doing this, then probably we could have come up with a sort of tutorial. Probably. I hate tutorials. I don't want to do tutorials anymore. But yeah, this might be a really interesting one to consider. Like just not writing anything from scratch. I already did this Wally chess engine, like implemented by following the didactic pseudocode implementation from the magazine of 1983, but some other guy writing a Go engine, Go playing program for Q1, unexpected Q1 with only 1K of RAM. So it's only like the capture machine, how I call it. Knows absolutely nothing about territory, but it's just trying to capture your stones. But with this, just bearing on this kind of modules, it might be really interesting to try to implement these. And yeah, this might be extremely interesting. Just bearing on this Sabaki tools. Why didn't they do this? I can't understand. They could have made a bot with this, but they didn't do. They have all of the tools. Why didn't they do a bot? I don't know. Okay guys, see you later and cheers.